Hello and welcome. So I finally got round to doing some Warhammer 40k nerd things, namely making the ROGAL DORN Tank radio controlled. But to make it more challenging and frankly make my life hard work, I decided to do it with Arduino and actually just code in a TV remote using an Arduino microcontroller to get it to work. So we'll go over the 3D printed parts in CAD first and then onto the coding. And if you like this type of thing and want to see more of it, I've got a great idea for a shadow sword, as well as the actual power armor project, which is the main thing of the channel. Please like and subscribe, as that will help the channel grow and pay for all these things. So onto the old Fusion 360.
So here we have the model built up, and on the sides, these are the main parts. These will hold the road wheels, which will allow the tracks to go around. To ease road wheel, sprocket and track alignment, I've decided to just have these pieces separate from the actual model, and you'll glue them into the model. And then if we rotate it around to the back, you can see where the 360-degree continuous rotation servos will be held. These are great as you can have easily adjustable speed. You have a gearbox built in with a little motor built in. You've also got custom sprockets which will fit on the servo horns. And then what you can see here with the road wheels is you'll have an axle that basically goes through each of the road wheels. Probably just some 4mm plastic bar. Onto what is always going to be the most difficult part of a project like this, and that is the tracks. I've got a few different versions to try. This one you can see here has the actual track pin basically printed in. It should work and it'll be easier, but it might have too much resistance when you try to turn it round. So I am going to try a standard metal pin. That'll just take a long time, as those will be printed individually and then I'll have to put them all together. I'm trying to have a good level of detail on them, including having the little pad that sits on the track, but I don't have a resin 3D printer, so I'm not sure if I'll be able to do that on a regular printer, if the supports will be a problem or they'll just be too weak. I might have to fan them up, but we'll see. Side note, I always think it's quite ironic that the Imperial Guard have Warsaw Pact compliant track treads, but anyway. And then we have the turret mount, so you've got this top piece which will allow a servo horn to sit on the top of it and be secured in. We do also have this other design at the back, but I think it will be too big and won't provide the right amount of clearance. But I'll print it out and try it anyway. And then underneath you can see the plate that will mount the servo in. That will attach to the actual body of the tank, allowing the turret to turn. So that's pretty much all of the parts. I'll flatten them all out and get them 3D printed, and we'll put them together and see what happens. And of course it didn't print it all out properly, but there we go. We'll count what's missing and put together what we've got. So I've got this servo mounting plate for the turret fitted in with the servo glued in. I just typically use glue gun because, to be honest, it's easy to use, and if you get it wrong you can just melt the glue off and try again. You can see how we've now got the corresponding plate mounted in the base of the model turret with the servo horn, which will allow it to fit onto the servo. I chose that smaller plate to do it with and basically just fit it all together and then glue gunned it all in place so it's all perfectly aligned. With the main chassis built up like so, I'm then going to trim the wheels off around the sides. So I've basically just got this interior part left, so all of this ridge line and all the wheels will be gone. That will then allow these pieces to be glued onto the side of the chassis, with of course these servos glued into the little holders. We've now got the servos attached into the track frame. So I'll get the wheels fitted to this, and then it can be glued into the frame of the chassis of the tank, which I've now put down. You can see there's not really much left to the sides of it. And that is all of the track wheels ready to go. I've got some 4mm plastic bar. You can use steel or aluminium, or even just print the bar, to be honest with you. I'll get this cut up into the axles, fit them all together, and then fit them into the track sides. And we've now got the sides assembled, servos in the back, all the road wheels on, all set the gaps, they all rotate pretty well. I will oil them up once I'm ready to fit the tracks. We've now got the track sides glued on, and then I'll just glue on the top with the turret and the servo. That will look like so. Normally on something like this I'd have the top removable for access, but because of the underneath of these tanks not having a bottom as standard anyway, and I've had to Lastly, you'll notice how I'm not fully dipping in the main part of the tank. That's because it does have the servos in. I don't want to get them waterlogged. But as long as I've got the pattern mainly over the front of the tank, it'll still look pretty good. You won't be able to see much over the back or this underneath anyway. As you can see, it's a pretty good pattern, so I'll get them cleaned off and then clear coated up and ready for assembly. Onto the electronics, we have a standard breadboard that's typical in most Arduino starter kits like the Elegoo starter kit. We have an Arduino Nano mounted to the end. And then we have the power jack, which allows an external power supply for a 9-volt battery mounted onto the other end. And then you have your little remote infrared sensor as such. However, what we do need to do is just bend the prongs vertical and then trim the top of the board off just to make it as small as possible. And then I will be attaching a couple of cables onto them just as a bit of an extension so they can then be plugged into the breadboard. I will also just use the glue gun just to tack these in place as well to make sure they don't come out when it's fitted in. I've also deepened the servo wire for the sensor cable on the servo. That way these little pin extensions can be put into the end of the servo plug. That way the positive and the negative can line up with the positive and the negative for the power jack, and the sensor cable can be plugged directly into the appropriate pin for the actual Arduino Nano. And what you'll notice if we turn the tank upside down, you will see how the Arduino Nano on this breadboard is literally the size of the gap underneath the tank, which with a tiny bit of trimming off the front will allow the breadboard and all the electronics just to slide up there and glue in. And you can see I've just fitted the infrared sensor at the back. We'll now just move on to a little graphic of the wiring. So starting on the top of my photo that frankly could have had better lighting, but never mind. At the top, you've got the power bars for the servos. So you've got the plus and the minus for all 3 servos, as well as the plus and the minus for the sensor. That entire bar is then powered by the power jack. It's worth noting that in the top right hand corner of the power jack, there are some little terminals you've got to flip around to basically take it from 3.3 volts to 5 volts. And then on the left, you've got the sensor signal wire in blue going to pin 3, if I remember correctly. And then you have the sensor wires for the servos going to, I think it is 6, 8 and 9. I picked these because they are PWM pins. It's not 100% necessary, but can help. So I just thought I'd go with it freeze. And then at the bottom, you've just got 2 power lines to link to the actual Arduino itself. So that can also be powered off the power jack. With that said, we'll move on to the code. So into Arduino IDE. First up, we have the servo library at the top and then the IR remote library. Then we have the servo pins below that and then the servo positions below that. Even though these are continuous rotation servos, they work the same as regular servos. So basically you have a position from 0 to 180, 90 being stood still, and then 0 being full speed one way and 180 being full speed the other way. So I'm trying out a twin speed method. So basically you're going to have a slow speed and a fast speed on each track in both directions. These servos do have to be inverted because they're next to each other. So one track full speed will be 0 and the other track full speed will be 180. And then that'll be reversed for reverse. And then for the slow speeds, you'll be about 45 degrees and 135 degrees. The turret though will just have a single speed. It is worth noting this is quite the experiment because I don't know how much of a difference this will actually make to the movement of the tank. The other problem is I can't really reduce these values down too far because I think the servos will become unbalanced. And because it's not a proper radio control remote, there's no way to basically trim that out. Hence why I'm going for the bigger end on the values, and we'll see if it actually makes a difference. And then below that, we have the servo names assigned to the servo library, as well as the IR remote sensor pin assigned below that. And then in the void setup, we've got serial begin, and then we have IR receiver begin, as well as just a little serial print to say that it's initialized saying receiver ready. And then I've got these servos attached, as well as a beginning point for the servo, so when it turns on, it will go immediately to 90, which in this case is the servo stationary. And then onto the void loop, you've got AR receiver decode, which is basically read what the sensor is receiving, and then serial print it to the serial monitor, which is where we get into hexadecimals. Now, I certainly do not have the time and probably not the ability, frankly, to explain all of this code in full and the exact workings of hexadecimals, but I will link a Paul mcwhertor Arduino tutorial video below in case you're interested and want to learn. But the key part here is on the left, you will see essentially like a code number, and it starts with 0x. 0x means hexadecimal, and then the following is the code for that hexadecimal. Now, whenever you press a button on your TV remote, it gives off a hexadecimal code. So what we're telling the system to do is to basically read that code that it receives off the AR sensor and then print it to the serial monitor. We then copy the code for that button and then insert it into the code, into these highlighted parts here. That then assigns that button to the desired function within the code. That way, whenever the AR sensor picks up that code, it will then carry out the desired function that you've coded in, thereby allowing you to program the buttons to move the tank. And what I've set up here is to have a forward mode, a forward fast mode, a left turn, right turn, reverse, a turn on the spot on 2 different buttons in 2 different directions, a turret left and right, as well as controls to move each track individually at each speed. You do then have a delay, so basically when you press the button, it will carry out that function for 250 milliseconds. I've just done this to stop any problems where it gets dropout or false readings or confused. If you don't put that delay in, you're basically working on microseconds, so any part of interference can basically interfere with the microcontroller itself. And what I will say, if you want to do any of this stuff, I do recommend you using AI to help you. Particularly Grok 2, I found that to be the best. I had a library problem with this. It'd basically been updated and I didn't know what had changed, and it was literally quicker just to ask AI to find it for me than it was for me to look through all the libraries to find the difference. But anyway, we'll get it uploaded and get it all coded in. I'm going to try to film it and try to film the serial monitor, but I'm going to have to basically hold the camera, operate the laptop and the TV remote for the tank. So I can't guarantee you'll be able to see everything, but I will do my best. Here we have the code put in and the serial monitor open on the left. You can see how it says IR receiver ready. And if we take the TV remote, aim it at the sensor and press a button, you'll see a code come up on that serial monitor on the left. Those are the hexadecimal codes that need to be transferred in. And as you can see, it now rotates the turret of the tank. I've now got it all programmed in and I've just glue gunned all of the wires in place to keep them secure. However, I will highlight a few problems I've had. The breadboard, i.e. the pin board, the one I picked happened to be faulty. The same with the Arduino Nano. For some reason, it wouldn't upload the code. I had to get another Arduino Nano. I then had a couple of connection issues, as well as having the 9-volt battery fail midway doing all this. So I've just got it hooked up to a power supply for now. But it is now time to secure all of those electronics into the bottom of the tank and get the tracks fitted. And I almost forgot, here are the sprockets with the servo horns fitted in to allow that easy fitment on the servos. We now have the new tracks with the track pins printed in. They do work pretty well, they are quite flexible. I have also tried some bigger road wheels up front, because I think a kind of a problem with this is the road wheels, the sprockets are quite small in relation to the size of the tracks. So for example, with a sprocket, you can only basically fit 8 tracks around it, so you've got a 45-degree angle per track. I think that's causing extra resistance, so I'm going to try one more time to make some more tracks with a lower amount of friction in the hinge and the pin to see if I can get them moving better and get the tracks tighter that way. And we finally have a winner. The individual link tracks do work better, it just took me about 2 hours to put them together. You will also notice there's a little bit of servo drift. It's weird, sometimes when you switch it on you get servo drift and then sometimes you don't. But either way, you can see it's moving pretty freely now. Forwards, backwards and turning on the spot, that's the manoeuvre that typically requires the most torque. I'll now get the sides glued on and get a battery fitted so we can see if those twin speeds actually make a difference. Now the sides are fitted on, I've gone to fit the 9-volt square battery into the back. However, I have found a flaw that unfortunately is a bit too late to solve at this part of the game. And that's that with the little plug on, I can't quite shut the back door fully. But at this point, it is what it is. And by the blood of dawn, it is finally finished. We have forwards, reverse, turret right, turret left. And then ignoring the servo drift, you've got turn right and turn left. And then of course rotating on the spot in either direction. As for the whole twin speed, this is slow speed and then this is fast speed. There is a slight difference, but it is only slight, I'll be honest. And then to finish off the little nerd trials, we've got a little 1 in 3 hill-ish. I'm actually quite impressed how those little cheap servos can do this. However, such abilities do come at a cost. The battery for this lasted about 4 minutes. So if you do want to take on one of these types of projects, I do recommend using a little lithium battery if you can.
And there we have it, a hydro-dipped ROGAL Dorn tank that is radio controlled and operated off a TV remote. Now, as for my idea for a shadow sword, because it's very 40k and the gun barrel is so big, I've worked out I should be able to fire a model rocket out of it. So if you want to see that, please like and subscribe. I've of course got that power arm project I was on about earlier. I should actually be able to make it powered fairly soon with my own actuators. The CAD files for this tank along with the code are also on Patreon, link in the description, as well as some other designs if you're interested. I'm also making a low vision Daredevil jacket with ultrasonic sensors, so please feel free to follow along and I hope to see you in the next video.